Hi, everyone. Welcome to our first ever webinar from securityreviewAI. And I'm really happy to be here. And I'm really excited to talk about today's topic, which is something that I think is going to change the face of how we think about threat modeling and security design reviews in the first place. So, this is something that I have seen a lot of our customers come up with as a common complaint, and this is something that we've solved in many ways. And I thought I'll discuss some of the approaches that we've taken and how you can be benefited by some of these approaches that we've used to solve this very, very complicated issue. And in a slightly different way, of course, with the help of AI, because this thing is supercharged when you use AI against it. So this is what I want to talk about today. I want to keep it oriented towards identifying this issue, talking about what this issue is, and then of course trying to figure out some of the solutions that we have with this issue in mind. So with that, let's get started. I'm going to start sharing my screen, and let's actually go ahead and get started with my screen. So the talk today is called using code to threat model. This is something that we've come across. We've actually seen this as a customer issue that we've come across multiple times. And this is why we built something in security review to do this. And of course, I'm going to talk about how you can do this yourself outside of just what we provide. Right, so this is using code to do a threat model. Now in this, I'm going to be talking about, of course, one of the big issues with doing this, which is the timing problem, and I'll talk about what the timing problem is. I'll also get into the challenge of docs versus code. Now most of us use documentation to do threat models and security design reviews. However, there needs to be a different way of doing this, and code is one way that we've thought of that you can do this, simply because code gives you certain benefits that documentation does not, and of course vice versa. But code gives you some huge benefits that documentation does not, and that's something that I want to talk about as well. In addition, we're going to be looking at how you can leverage code and AI for threat modeling. Now, this is really the stuff that makes a lot of sense to do this, because again, code is large. Most of the time, you're dealing with source repositories that are pretty huge, that have a lot going on. So, obviously, how you can leverage this is leveraging AI, right? AI really helps you do this quite extensively in a way that you don't have to spend hours and hours looking over this as a human being. So that can help. And of course, let's look at some unique opportunities and conclusions with this topic. Right now, this topic is something that we've been grappling a lot with, because, and I'll give you a little bit of background about why this actually happened. Right, we had several customers coming to us and say that, look, yes, you want us to do threat modeling with documentation, and this is not only now. This is even before I built an AI threat modeling product. We used to have scenarios where customers used to come to us and say all the time, "Look, I mean, you're talking about having documentation and specifications and PRDs and diagrams and all that stuff, but we've just gone about building the product as is. We've not really taken the time to do a very good job of documentation. Is that perfect? Obviously not. It's not something that we wanted to do. We really wanted to document, but hey, we never just got around to doing it. And that's something that they complained about most of the time. And they were like, why can't we use code to do the threat model? And in some ways you could, but there was a lot of complexity to it. So the idea was, can we use something else other than documentation, which a lot of these companies and a lot of your teams yourself may not have? And can you use that instead of code from a I mean, can you use code instead of those documents that they don't really have to do your threat models? That's something that we're going to be exploring in this particular session. So let's talk about why this happens and some of the common problems here. One is, of course, all of us get started with this utopian view, right? Like, let's do threat modeling and let's bake it into the design, and that's how it should be. Really, you need to bake threat modeling into design, and every single time you want to be able to do your design and evaluate your design from a security perspective, produce your threat model, and then go ahead and start building the code. Then use the threat model to start securing every other aspect of it, or give you ideas to secure every other aspect of it. So the idea is always to do it this way. Let's start threat modeling and bake it into the design and make sure that we do it continuously and all of that stuff. That is good. I'm not saying you should not do that. You should definitely do that. But in most cases, you are dealing with this. You're dealing with existing applications. You can't just think about, oh, I'm going to do threat modeling for only new projects or new applications that we build. You are always going to be looking to do threat models for your existing stack, your existing apps. But as you start doing it for your existing app and your existing stack, you're dealing with the pink dragon here, which is it's massive. The system is huge. It has a lot of tech debt. It has a lot of connectivity. It's a lot of stuff that's going on. The system is pretty large, and that is overwhelming, right? The existing app that you're looking to threat model. Let's just take on this project as a pilot or whatever. I've seen this happen so many times where we go into a client, especially in the services side, we go to a client and they said, okay, let's just take this project, and that project is not a small project. It's usually huge. It has a lot of moving parts. And when you are threat modeling that project, you are looking for documentation, and a lot of time the documentation just does not exist. It does not exist. It just straight up does not exist. They probably have some old documents. They have some Jira tickets. They might have some um, diagrams that they created. And what happens then is you are either stuck between a rock and a hard place. If you're an external consultant, you have to dig through the documents. Even if you are internal, you are digging through documentation which they don't have. Whatever you can find, sometimes you're calling people for meetings. You are working around the problem all the time. Yeah, you're always working around the problem because there is no documentation. At least there's no good updated documentation. There's probably some old documentation or not very well maintained documentation. There are all kinds of things happening, and because of it you are calling people for endless meetings, and this is something that never works out, right? Threat modeling is one of the reasons why threat modeling is has not really taken off when in the modern corporate organization is simply because a lot of it depends on meeting people a lot, and meeting people a lot is a recipe for something just not happening. I know we would like to say, yes, let's collaborate on the threat model and so on, but if it has to be a synchronous collaboration in the form of a meeting, especially with senior people who are involved in a threat model, which they should be, because your threat model needs people who are not only highly entrenched in the project, but also senior enough they understand the big picture, you will see that this fails. Most people don't want to meet. They don't want to take the time to meet. It takes a long time to do these meetings as well. So every time you have to arrange a meeting, you're taking people away from their core activity, and that's something that people don't like to do. So this is you're going into this endless loop, and because of that endless loop, you are ending up here, right? You start off a threat model with a lot of hope and a lot of with a lot of expectation of good things to happen with the right intentions and so on, but you always end up with um, being tired and producing something that is not really effective most of the time. The worst part is not just the being taking it it being a laborious complicated task. I would say the biggest problem that I would see with threat modeling is that it ends up being a futile, almost useless exercise because of that, because you just gather whatever you can, you do a best case thing, and you go with some generic threats, because again, you don't have all the pieces of the puzzle when it comes to your product documentation, and you can't look at every possible thing. You don't have enough resources, you don't have enough time. I've been on that side of the product security team, and when we've done that, we've always seen that it ends up with you being not so satisfied with the outcome, but hey, there's something that you can check off and say, okay, we've done a threat model and move on. Right. So this is something that happens more often than you think. I'm sure many of you watching this, especially in the product security space, are going to resonate with me very, very hard. Simply because you will see that this sort of stuff keeps happening, and it keeps repeating. The cycle keeps going on and on and on. Right. This happens a lot. Now, what is the actual problems are, of course, you still need to You need to do existing threat models. You need to do existing product threat models. You can't just look at only, okay, I'm only going to touch this greenfield application development thing and only that we're going to threat model. That's not going to work because you are either mandated, you have some requirements that you need to do threat modeling for, and that's not going to work with this. Or you don't have the documents, you have outdated documents, which is something we've covered. You can't meet people too often. It's not a priority for them. This is something we've seen, and you end up with an unusable generic mush of a threat model. And we've seen this extremely often. It's not even a joke at this point. This is pretty bad, right? So these are the problems. Now, one of the things that we've realized, and you'll see this, that we've seen this a lot as well ourselves, is that look, there is one source of data that you should be able to use, but you don't use for some reason, and that is the code, the actual source code, the actual application source that you don't use for some reason. For several reasons you don't use it, and some reasons are legitimate, some reasons are not, but you don't use it. Instead, you're always trying to do the whole docs and diagrams and stuff like that, but end of the day this doesn't work. And I'm not saying don't do docs and diagrams. If you have docs and diagrams, please use those. I have no problems with that. But I'm saying a lot of times you don't have it, and it might be that if you could use code, could you get results better, faster, and much more effectively? Is that possible? Let's talk a little bit about that, right? So, here, the code, again, when you want to use source code, there are a few challenges that you hit when you want to use source code, which is why I think a lot of people have not considered using source code to do a threat model. There is just way too much code, right? Um, there's a lot of code, there's a lot of stuff going on in your code base, and that might be one of the reasons. But let's talk a little bit about the benefits of threat modeling with code as the basis, or as your raw material or your bedrock, so to speak, right? So when you're looking at that, one is your application source code is always going to be maintained, and it is going to be an undeniable source of truth. You cannot have a repository that is out of date. It's just not possible. Simply because your repository is the way you ship your application. Your application, that is the real ground truth to your application. There's nothing more true than your source code, right? There's nothing more true than your source code. That's just the way it is. So it is this undeniable source of truth and ground reality. In fact, you might have documentation that looks extremely nice and rosy on the outside, but doesn't keep up with reality because the documentation was probably just written at one point and it doesn't really keep up with reality. But with source code, there is really no question about it. It is ground reality, right? Undeniable source of truth. It's always updated because, hey, if you don't update source code, you don't ship your apps, and if you don't ship your apps, you basically you have nothing to stand on, right? It is mandatory to stay updated in terms of your source code. It's a lot more detailed than documentation. Now, documentation always reflects the state of what you want things to be. Source code is typically not just what it is, but how it has been implemented, why it, and in many ways, how it has been implemented, how it has been deployed, how it can be made to deploy, how it can be tested. All of that stuff is part of source code in many cases. And of course, with modern repositories, like I said, modern repositories are not only just a source of application source code, they are also repositories for infrastructure as code. They're repositories for CI manifests, your deployment manifests, your tests, your test cases, and so on. They're repositories for all of this stuff. So they're like this uh, mono repo that contains, in a lot of cases, it's a mono repo. I'm not saying it's all the time, but there's a mono repo that contains all of these things, all of these elements. And because it contains all of these elements, your ability to perform the threat model would be a lot more complete. So you don't only look at the application source code, but if you leverage the entire source, you are able to not only look at the application source, you are also able to look at how it's going to be deployed, how it's going to be built, how it's going to be shipped, all of that stuff, right? It becomes a very important source of truth as far as you're concerned, right? So that's something that you can do with source code. And those are one of the benefits of source code. So let's talk about the limitations of this. Obviously, source code has some benefits, but let's talk about the limitations of this as well. The limitations, obviously, Source code is large, complex, and dense. You are a security team or you're a security professional. You do not have the bandwidth to deal with a huge code base, right? You might be good at code. You might even have been a developer in your previous life, but just dealing, if somebody just dumps a large code base on you or your team, you are not going to be able to deal with it just off the bat. It just doesn't work because it's huge. It usually has a lot of moving parts. The application has a lot of different interfaces of different classes and different abstractions and so on, and becomes a little complicated for you to use this to do a threat model, right? Not much feature context. A lot of times, source code might tell you how a feature has been implemented, but it may not tell you why a feature has been implemented. And that's really where the documentation thing kind of plays a role, right? The documentation will tell you why and what is the intention and what is the user story and what is the feature description and the feature essays and so on. But the source code tells you how it's been implemented. Source code does not give you much insight into why the feature even exists in the first place, right? So that is something you don't get from source code, which is a limitation. And but that's something that you have to contend with, right? That is something that you have to contend with because it gives you quite a bit more value on the other side. So the cost versus benefit, source code definitely wins because it gives you the implementation. It also does not always give you runtime or environment insight. Now, this may happen or may not happen. It may happen because your source code might just be that, it just may be the application source. But if you have infrastructure as code, scripts in there, manifests in there, and so on, this also is a limitation that's not a limitation anymore. You essentially have that also being overcome in the form of infrastructure as code, CI build, scripts and manifests and so on. So all of this stuff is there. Now, also, there might be a scenario where you have little documentation about the code. So if you have the code, yes, but if you don't have too much documentation connecting you to the code, then again, it becomes hard for you to determine what to use, how to use, and why to use it. And that becomes a limitation when you're using code as the basis to perform your threat model. That's something we're trying to see. Now, where does AI come in? And AI is really the protagonist of the story here because AI, what it helps you do is that it helps you break down large code bases into something meaningful that you need for you to do your actual threat model. So remember, what we need here is we need to be able to take some source code of our application or our system, or it could be multiple repositories of our application and our system, break that down into some kind of consumable data, which means something that we can use to perform our threat model, some kind of input that we can use to perform our threat model. Just like we break down a diagram or break down a document into something that we can use to perform our threat model. The same thing we need to do with source code, and that's where AI comes in. Because with AI, you can break that down into an output that becomes an input for your threat model. And that output is actually discernible not only to humans, but also to other AI systems that you can use to build out these threat models, right? So that is something that you can do with AI, with and source code, of course. So where can you do this? You can either do this at a point in time. So let's say you are into point in time threat modeling, where you do threat modeling once in a whatever quarter, once in a month, whatever it is. You can do it with this. You can say that, okay, in point in time, I'm going to take up a specific code commit and I'm going to perform a point in time threat model of that, which is not a continuous threat model of any sort, but I can do that. Or you can go the pseudo SAST route and say that every single time there's a pull request, I want to examine changes in the source code to determine if there's anything risky in the source code, right? So any new attack surfaces, any new any new data sets consumed, any new sensitive data sets added, any new risky calls done, so on and so forth. Anything new in terms of functionality that are added in terms of cryptography, any new security controls that you've introduced, all of this stuff becomes an important thing that you can trigger. So you can trigger it in two ways. One is a more point in time approach, and the other is a more continuous style approach. Both these things have a place, right? And again, I am not saying, again, I just want to be very clear here when I say this. It doesn't mean don't use documentation at all. If you have decent documentation, please use it. A lot of times that might be more helpful than source code, but there's no reason why you can't use source code also. right? So that's the point here. So it could be point in time where you're doing these, okay, we are doing this release and we are going to do it at this point in time. Or you're going to say that every single pull request from this branch to this branch, we're going to trigger um, a, a security design review or a threat model, and we are going to do it that way, right? So that's those are the two ways in which you can do this, right? Now, what is the thing that you need to do? So one of the things that we discovered works, and we've implemented this in security review as well, is that, remember, source code is huge. You're dealing with a lot of moving parts, and because you're dealing with a lot of moving parts, you're also dealing with the complexity of the size of that or the scale of that problem. So, what we discovered was that if you approach this like you would train a new developer in your source code. So, imagine you've onboarded a new developer and you've just made that person, part of this team that's handling this particular application, and you've given them access to the source code. Now, that developer is going to have to learn about that source code, right? They're going to have to learn about what that source does. So how would they do it? So our idea was, why not create a bunch of agents or code profiling agents that will walk through a code base and use that, though that what they've learned from that, to create a guide as if it were a guide for a new developer who is suddenly being onboarded into this code base, to understand what is happening in this code base. And using that, we created an agent that could help you do this. So the idea is that this becomes your input, and you use this input to perform a full-fledged threat model, right? That's the idea here. So you basically take the AI agents that walk through the code base and create a guide, like they're training a new developer on the code base. Then you pass this guide into our threat modeling agents that will automatically analyze that. Oh, this is what's happening in the system. These are the risks, etc., etc. Come up with a full threat model. So this is what we ended up building, and this is really something that we've seen immense benefits in terms of us doing it, because our customers have started using this and have said that, oh my god, this is really a game changer. And the reason it's a game changer is because they can just go in with zero documentation and they can produce an extremely viable threat model, right? So you can, but the step-by-step approach that we used is, one, gather key abstractions. Okay, your code base is going to have a ton of different abstractions. Gather the key ones, the more critical ones. If you can even gather other ones, but ideally stick to some because they'll have relationships, right? Then you establish relationships between these abstractions. More often than not, you are going to see a ton of relationships and data flows between these abstractions, right? It could also be between code bases, right? It could also be between code bases. Then you basically analyze the security risk abstractions relationship. You come up with this guide sort of thing for all of this, and you create something we call a code profile, right? In security, we call it a code profile. This code profile essentially has these abstractions, their relationships, their security risks, their risky patterns in some cases as well. And this code profile goes into our threat modeling agents and then performs the threat model, right? So that's how it works. So the idea is that when you are doing this yourself, one of the things you have to do is take similar approach, if you'd like. Take the key abstractions in your source code, which could be classes, which could be functionality, break that down, establish relationships between those abstractions, and then use that as your basis of formulating your input. Come up with your profile, and then use that profile to actually perform your threat model with that profile. So that is the benefit of doing something like this, right? So this way is something that we were able to break down a very, very complicated issue when it came to threat modeling, and we were able to perform this in a much more meaningful way, right? In a much more serious way, right? So that is something that we were able to do, and let me show you a bunch of demos as to how this works. So in our case, so I'm going to talk about a project that we've taken up, just an example project here. So we've done a threat model for Defect Dojo. Defect Dojo is an open source vulnerability management tool. It used to be an OWASP project. Defect Dojo basically allows you to, the way it works is you have application vulnerability scan reports from Zap and Burp and SAST and all of these different tools. You can push it into one single place and manage those vulnerabilities, and of course manage the life cycle of those vulnerabilities from that point in time. So that's what Defect Dojo is. So what we did was, all we did in security review is loaded a Git repository. So in security review, you can just create a Git repository and then pull the data from that Git repository and then paste the URL, and that's it. It'll just profile that entire Git repository. Once you do that, what security review does is use the code profile tool to build out something called a code profiler, right? So this will basically build out a code profiler. And this code profile, what it does is that it essentially builds out all the different, so it, like I said, it builds it out like as if you are training a new developer on this code base. So it builds it up like a book, if you will, right? Or these are the models that are there in Defect Dojo. It tells you what are the key pieces of code, what are the relationships, and it tells you these are the security considerations for this, and it tells you the next one. So in fact, it gives you some very insightful things. So for one of the things that we found was, let's say, the scan parsers one, which is chapter 3, which is a very key part of Defect Dojo, which is, it has to parse all of these different scans and then come up with the scan, then actually normalize them into a vulnerability data set and then deduplicate and so on. So the scan parsers are a very important part of Defect Dojo. And the way it works is that, so you can see that in the scan parser, it's identified all of these different abstractions, relationships, and so on. And then once it's done it, it's identified security considerations, and it's identified on the money. It said that one of the big things that I'm worried about here is XXE, because a lot of these scan tools produce XML. And it even gives you diffused XML, specifically hardened, but it's a crucial defense. This is great because it gives you some very interesting security profiling insight into how that works. And not just that, you can see it gives you some very useful diagrams. All of this, you can in fact just take this and give it to your new developer to the project, and also use this for threat modeling. So it's not just that it helps you do one thing, but it also helps you do the other thing, right? So this is something that you can do, and we've delivered a threat model from this, and you'll see that it actually produced some very interesting insights. Like, it has clearly identified, cross-site scripting and custom report templates, because the reporting engine does a lot of HTML templating. It's identified insecure direct object reference in the API. It's not, by the way, these are not vulnerabilities, these are threat scenarios as to what can happen. It's identified XXE in the scan parser, something that it identified in that profile. So you will see that it has identified very specific things that speaks to very specific elements of that particular code base and of that particular product, and with the technology parameters of that particular product. It's not gone off beyond it, tried to give you some random stuff. It uses celery, so definitely celery issues are there, or celery issues might be there. It's identified all of these things very, very realistically. And that's the benefit of using source code, right? One of the benefits of using source code really is that it can help you break this down into something extremely meaningful. And because it helps you do that, it helps you get a much better context. And remember, source code is there. You don't need to worry about the documentation. You don't need to worry about curating it or maintaining it or creating diagrams from it. Source code exists, it's there, it's always there. So you can leverage that to do your threat model. In fact, the other type that I was talking about is in our continuous threat modeling system. In fact, we have, so this is a just a example payment software, and this, every time a pull request is created, we have a feature which analyzes that pull request for security issues. So you'll see that there are risky code patterns. It says that, okay, this is the attack surface, these are the concerns, these are the requirements, these are the recommendations, and it tells you what you need to do in each of these risky. So the idea is that it kind of behaves like a pseudo SaaS in some senses, but it's not really that. What it tries to do is look at the thing, look at the attack surface, look at the breakdown, then it tells you that, okay, this seems to be a little risky, this seems to be a little risky, and so on. So again, like I said, you should approach this from two perspectives. One is from a point in time perspective, and the other is from a GitHub, more a continuous review type of perspective, like we have done with GitHub pull requests here. So the idea here is that exploring both makes a lot of sense. Again, this doesn't mean that you should not do um, document based or use documents to do your threat model. Documents can fill in the blanks where code does not, right? It also will happen that the document add a lot of useful context as to why certain things are a certain way, and that's something that makes a huge difference when it comes to um, document based as well. So don't think of this as an either or, it's an augmentation that you can think of it from that process, and then use that to build out a much more effective threat model. And remember, not just a more effective threat model, but a faster threat model. Remember, that's what we're here for. We're here for speed, and you should not be sacrificing speed at any given point in time. So this helps you achieve that quite a bit, and that's one of the things that I want to talk about today. I thank you so much for your time today. And I'm available on LinkedIn if you have any questions. I'm available on my social. It could be on Twitter, LinkedIn. LinkedIn is typically the best way to reach me. You can find me on LinkedIn, ask your question. I'll be happy to respond with any answers that I can. Thank you so much for watching, and I'll see you in next one of these sessions of ours. Thank you so much. Have a great rest of your day.